Okay, so here we have the answer for example 2. We multiply them, and here will be the answer for example 3. We are distributing 2x times x plus 4 and negative 2 times x plus 4. So now we go here and we distribute 2x times x, so that will be 2x to the power 2. Then 2x times 4, so that will be plus 8x. Then here we'll have negative 2 times x, that is negative 2x. And then negative 2 times 4, that will be negative 8. So after this, if we combine like terms, like the 2 here in the middle, that will give us positive 2x squared plus 6x minus 8. And that will be the final answer just for the equation. Here, they're not really telling us to equal it to anything, so I'm just going to write down this y. Okay. So the goal of those problems on the lesson was to break a polynomial into 2 factors. Well, that's the goal for this lesson. So that was like our warm-up. So for example, if I give you a polynomial like that, it could be written as the product of these 2 factors. And then we could go, if we multiply the factors, we will get back to this one. So if we go in this direction, we call that multiplication or distribution. Or you multiply, that's the action that we take. And if we go in the other direction from the full equation to the factors, that's called factoring. And we care about that because if you have the 2 factors, you could equal those 2 factors to 0. Then you can set each factor equal to 0 by itself and then solve for x. So this will be x equals 3. The other one, you take the factor x minus 2, equal it to 0, and then solve for x, so you will get x is equal to positive 2. And so that's why we care about factoring. So we can find the solutions, and that helps us to find the x-intercepts. And of course, it's helpful to graph any equation. So whenever you factor polynomials, the first thing you should do is, and now like we're going to factor even the higher degree. So first thing to do is look for a GCF, or like to see if you have a greatest common factor. So that could be and another different than 1, right? Because factoring out a 1, it's not useful. So anything greater than 1, like if they're all divisible by 2, the coefficients, or if they all have like x cubed, x squared, and x, then maybe you could factor out an x before you consider any other factoring techniques. Now, if there are 2 terms, you should ask yourself, okay, are they a difference of squares? And here we don't have it, but we also have this other one's called sum of cubes, and another one is difference of cubes. Now, with squares, only difference of squares could be factored. If it's a sum of squares, then it's not factorable. Okay, now if you have 3 terms, then you should ask yourself, are they trinomial of the form where x squared has a 1 in front of it as a leading coefficient? Because those are easy. But if not, if it's something bigger, that's why we generalize it here with the letter A, then those are a little trickier to factor. However, there are a lot of techniques for that, one of those is like breaking it into a term, an expression with 4 terms. And once you have it broken into 4 terms, grouping is like a very useful factoring technique. Now, if you're allowed to use a calculator in your class, then you could always graph it and see where it's touching the x-axis and work yourself backwards. Because if you know the x-intercept, you know the solution or the root or the 0, the x value. Okay? So for difference of squares, those are terms that have a perfect square for both. Like in this case, x squared and 64. That means we can take the square root of both and get just a variable or an integer. And that's what we do. We take the square root of both. We make one positive, one negative. For trinomials, if it's something like this, you know, they're not that hard to factor. Like this one, we found -7 and +6. The product of those gives you -42. And then if you add them, -7 plus 6, you will get -1, which is what we needed here for -x, the term in the middle. Now the second one, if you notice, they're factoring out a 2 first as the GCF because every single term there had was divisible by 2, like 2w squared, 20w, and 50. So you do that, and then you factor that as the product of two binomials. When we have by grouping, you have to separate your 4 terms into 2 groups, and then you factor the GCF from each group individually. So in this case, it was a squared. In this case, it was 5. And then based on that, the first factor is the one that repeats, in this case, the 2a minus b. And then the other factor comes from here, a squared plus 5. So let's do some of those examples by using that chart. Okay, so to factor by grouping. So for example, if you have to factor the number 18, one of the things that you should consider doing is using prime factorization. Now, some people like to do the trees. I don't really like that, so I prefer to write them this way. And here I'm going to list on the right side of that line the numbers that I can use to divide 18, but only prime numbers. So 18 could be divided by 2, I will get a 9. 9 could be divided by 9, but I want to take a prime number, so I'm going to divide by 3. So 9 divided by 3 is 3. Then 3 can only be divided by 3, and that will give me 1. Now, once I get a 1, I stop, and that's how I know that this combination is the prime factorization of 18. So 18 is the product of 2 times 3 times 3. So, or I can say that 18 is the product of 2 times 3 to the second power, like that. So now on the next example, we're going to factor out the greatest common factor. So that is the same as the GCF, greatest common factor. And so if you see this expression here, we have x to the third power, x to the second power, and then we have x. And so what we're going to take out of here will be x, because they all have it to the smallest power, which is 1. But also, you notice that all coefficients, the big numbers, they can all be divided by 2, correct? So then we're going to factor out 2x. So for the first term, we have 6x to the third power, and if we factor out 2x, we divide the coefficients. 6 divided by 2 is a 3. And then with the variables, we subtract the exponent, so that will be 3x squared. Now the next one, we have 4x squared, and we're going to factor out 2x. So that will be 2x positive. And then the final one here, we have a 10x, and we want to factor out 2x, which is kind of like dividing by 2x. So that will just give us positive 5. So plus 5. Okay, now here, we're going to factor that trinomial into the product of two binomials. So 3x squared, to factor that, we can only do 3x times x. And then thankfully, the sign of this term, the third term, is positive. So that can only tell me 2 things. Either both signs here are negative or they're both positive. Based on this sign here, it tells me that they're both positive. The factors of 5 are only 5 and 1. So we just need to see where we will place them. Now, to make sure that we have the correct factors here, we will take, check the outers, so 3x times 5, that gives me 15x. And then the inners, 1 times x, that will give me 1x. Everything's positive, so if we combine, we get positive 16x. And that is not what we need. We need a positive 2x. So what does that tell me? That I need to change the placement of my constant terms. So I'm going to do that. I'm going to put the 5 here and the 1 here. So now let's try to check. So 3x times 1 is equal to 3x, positive. And then 5 times x is equal to 5x. And so if we add them, we will get 8x. Now, because we already tried all the possible combinations, and none of those work, then we could say that our answer will just stop here. Well, we could still find the solutions, but we will have to use the quadratic formula. So what this means is just the factors, the numbers that will give us the solutions are not going to be integers, but they could still be some expression with a square root, like a radical, or they could still be a fraction. So, or maybe that they don't exist. Okay, the next one, hopefully that one we can factor it. So you see the coefficients, you have 21, 18, 27. Those numbers can all be divided by 3, right? So we are going to factor out a 3, but we're also going to factor the variable with the smallest power. So that would be the x squared. So we factor out 3x squared. So that means that for each expression there, we're going to be dividing, right? So first, we get that 21x to the 4th, and we're factoring out 3x squared. So 21 divided by 3 is 7. X to the 4 divided by x squared. We subtract exponents, so we will get 7x squared. Next expression is negative 18x cubed, and we're factoring positive 3x squared. So that will be negative 18 divided by 3 is negative 6, and then x cubed divided by x squared is x. So that's going to be negative 6x. And then lastly, we have that 27x squared. We're dividing by 3x squared, so that will give me positive 9. That's it, positive 9. Okay, so let's see if we can factor this one. And let's see, so we have 3x squared. I'm going to do this here. And let me go ahead and introduce you to the factoring by grouping, okay? So what we do is we take the 7 and the 9, all right? And that will give us, we multiply them. Positive 7 times positive 9 will give us positive 63. Now we're going to write down the factors of 63. And just a heads up, because this is negative and this is positive, the 9 being positive tells me that both signs are of the same sign, either both positive or both negative. But because we have a negative 6 here, that tells me they're both negative. So right here, we're looking for negative factors, all right? That when we combine them, we get negative 6. And so if we just multiply 3, well, factors of 63, we could say negative 1 and negative 63. Or we could say negative 3 and negative 7. I'm sorry, that's not right. So what is 63 divided by 3? Is that 21? I think so. Or 63 divided by 7, and we will get negative 9. So out of these combinations, none of those will give us -6, which is also kind of weird. So then we'll just stop there. So then this will be the solution. Now, to answer the question that you asked me earlier, to find the last, let's say that the question was find the zeros. So then as you go on chapter 2, you're going to learn other techniques to find the remaining zeros. So one of those is going to be division, long division, or synthetic division, and then you're going to learn some theorems as well, like the rational zero theorem and things like that. But also, like right here, what I will do if my question was find the zeros, I will go ahead and use the quadratic formula, the -b plus minus square root of b squared minus 4ac, and then divide it by 2a. Okay. Now with that one, just not being factorable, we could just say that that's it. That's as far as the factorization will go, but it doesn't mean that doesn't have zeros or solutions, okay? They're just not integers, and that's what I was trying to do. So now let's do this one, factor by grouping. So first thing we do is we're going to make two groups. We have 4 terms, right? 1, 2, 3, 4. They're separated by the positive or negative sign. So I'm going to group the first two. So 4 minus 2x squared. And then I'm going to group the next two. But I'm going to put a plus because here I'm just grouping them, but they're still adding each other, okay? So that will be x squared y cubed minus 2y cubed. Now from here, I'm going to factor a GCF from each group. So from the first one, I'm going to go ahead and factor out a 2. And that's it. So if I factor a 2 from there, I will get 2 minus x squared. From the next group, I'm going to go ahead and factor out, if you notice, they both have y to the 3rd power. So I factor that out, and I will get x squared minus 2. Now, they're almost the same, and what I mean is what's inside the parentheses, okay? Except that the signs are opposites, right? So what I can do is, instead of factoring out a 2 here, I could factor out a -2. So if I take 4 and divide by -2, I'm going to get -2. If I take this expression, if I divide by -2, I will get positive x squared. So now, if you notice, now they are the same, except that the order is different, but they have the same sign. So I can go ahead and just change that. So I will have x squared first, and then minus 2 coming from here, and then plus y cubed, parentheses, x squared minus 2. Let me delete this here. Okay, now in this factoring by grouping, what you have to do next is you look at the factor that is repeating. So in this case, this one. So that will be your greatest common factor. It just happens to be a binomial. No. So if it's repeating, it's kind of like if they had like this big W here. Like if you had -2w plus y cubed w. So they both have w, right? So that is the first thing you factor out, the w. No, we want to break them apart. So we look at what they have in common, and that's what we take out here, w, okay? So if I take this term, -2w, and I factor w, I still have -2, okay? If I take this term and I factor out the w, I still have y cubed. Okay? So now with this one, they both have in common x squared minus 2, correct? Do you see that? When I say both, I only say 2 because this is 1 complete and this is 2. One term, 2 terms. Factors, the factor in common will be this one. So once we take that out of this whole thing, what do we have left? Negative 2. If we take x squared minus 2 from here, what do we have left? Y, positive y to the third. Just like we did here, but here I put a w, right? And that's it. Those are your factors. I mean, you could always rewrite them so the first one is positive. So it will be x squared minus 2 times y cubed minus 2. And those will be the factors, the final answer for that question, just to factor that. Now, the steps for that factoring by grouping, which is what we just did, are listed there. So you group terms with common factors like we did here. We made a group with the 4 and negative 2x squared. We also made a group with the last 2 terms because they had factors in common. Then we factor out the greatest common factor like we did here. We factor out a 2 and we factor out a y cubed. And then after we do that, of course, we have to do the process of factoring them out after finding that GCF, and then you could go back and check by foiling to make sure you get the same thing. Okay, now next one, let's just go ahead and factor it. We don't have a lot of space here, but it will be quick. So we are going to group the 8 minus 4x to the second power, and then we're going to group the x cubed y minus 2xy, but we're going to put a plus in between them, okay? Then from there, we're going to factor from the first group. We're going to factor out a 4. Let's try to factor out a negative 4. So if we factor out a negative 4, 8 divided by negative 4 is negative 2. Negative 4x squared divided by negative 4 is positive x squared. Next one, we're going to factor out a positive y because they both have a y in common. And if we do that, we will get x to the third power. Actually, oops, my bad. Let's go back here. Let's factor not just y, but let's factor xy. Because they all have x to the first power. So we factor xy, then we will get x squared minus 2. And now that one is almost the same as the previous, so I'm just going to rewrite it this way, negative 4. And then I'm going to switch this binomial, the order, so it will be x squared minus 2. And then here we will have plus xy, parentheses, and then x squared minus 2. Now from there, the factor they have in common is the x squared minus 2, this one. And remember, the other factor will come from here, negative 4 plus xy, like that. And that's it for those factors. Okay, let's see what we have next. Okay, so this one is also by grouping. So I'm going to go ahead and group the first two, x cubed plus 5x squared. And then I'm going to put a plus here and then negative 2x minus 10, parentheses. So from the first group, I'm going to factor out x squared. Then I would get x plus 5. From the next group, I'm going to factor out a -2, and then I will get x plus 5. So now the factor that they have in common is the binomial x plus 5. That's going to be my first factor. And my second factor will come from here, x squared minus 2. To check the answer, I will leave that to you, but what you will do is multiply them and see, and if in fact you get the same expression, x cubed plus 5x squared minus 2x minus 10. That's how you will check. Okay, let's do this last one. I think we can do 2 more. So I'm going to group the 3x to the third power minus 2x squared. And then I'm going to go ahead and group the -6x plus 4. You see how I'm still using a positive sign here because I don't want to really change the sign of the positive 4. So from here, we're going to factor out an x squared because that is the smallest exponent here. So if we factor x squared from 3x cubed, we're going to get 3x. If we factor x squared from -2x squared, we get -2. From the next one, I want to factor a -2. Why a -2? Well, because when I factor the -2 from this -6x, I want to be able to get positive 3x so that it matches this other 3x here. So 3x and then positive 4 divided by -2, we get -2. So you see now they are identical right there. So that's our first. And then our next one comes from x squared minus 2. Okay, let's do the one more thing. Okay, so right here, we group the x cubed plus 2x squared, and then we group the -9x minus 18. So first group, we take x, but to the smallest power that we have here is the 2, so we put x squared. X cubed divided by x squared, we get x. And then 2x squared divided by x squared, we get positive 2. The next one, we're going to factor not a 9, but a -9. Because from -9x divided by -9, we get positive x. -18 divided by -9, we get positive 2. And so that way they match, right? So we take those two as our first binomial, x plus 2. And then our next binomial comes from x squared minus 9. Now that x squared minus 9 can be factored even further because it is a difference of squares. How do we know? Because x squared is a perfect square and so is 9. So we take the square root of x squared, that will be x. And then the square root of 9 will be 3. And then we make one positive 3 and one negative 3. And that's it. That will be the complete factorization of that polynomial of degree 3. So let me see how much we have left here. Okay, so we have one more page. So it's time to go. So let me just finish factoring this ones, and then I will send you the link with the rest of the problems. Okay? All right. You're welcome. See you. Hace cuenta que yo me he cansado. Okay, so we're going to continue. So we did finish those up to example 8. So let's go ahead and move on to 9. And so for this one, we're going to factor it as the product of two binomials, and that will be x and x. And then the factors of -6, remember we will have a positive and a negative sign. However, the number with the biggest absolute value will carry the negative sign. So it could be +1 and -6, or it could be +2 and -3. The combination that will give us a -1, it will be if we add +2 minus 3, so that will be equal to -1, and that is what we need here, -1x. So we're going to go with -3 here, +2 here, and those will be the two factors. For the next polynomial, again, it's the product of two binomials, so it will be x here, and the factors of 60, we're going to go ahead and list them here. I usually like to write them in this way, the small number on the left and then the large number. With this sign being positive, that tells me that my signs here will be either both negative or both positive. However, since this is positive, that indicates that they're both going to be positive here. So factors of 60, we could have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. They're all positive. And so if we add any of those combinations, the combination that will give me a +16 will be this last one with a +6 and a +10. Okay, now I'm going to move on to factor example 11. And right here, we could have several combinations. So what I'm going to try to do is multiply the leading coefficient times the constant term. So that will be +2 times -4, and that will give me -8. Now I'm going to go ahead and list the factors of -8, starting with 1 and 8. We know that 1 will be negative, but based on this -7, that tells me the column of the large factors will carry the negative sign. So it will be +1 and -8. Or I can have +2 and -4, or actually that's it. Now we look for the combination that will give us -7 when we add them, and that will be here. -8 plus 1 will give me -7. So what I'm going to do is break that term, -7x, into -x and +8x, or actually the signs will be the opposite, -8x and +1x. So in this case, I want to write down the -8x first. So 2x squared minus 8x plus x minus 4. Then I'm going to go ahead and use the reason I'm breaking this one into 2 is so that I can factor it by grouping. So it will be 2x squared minus 8x. I'm going to close the group plus, and then the other group will be x minus 4. From the first group, what we can factor out is a 2, also an x. And if we do that, we will get x minus 4. Now, from this next group, the only thing we could factor out will be a +1. And if we factor out a +1, we will get the same binomial itself, x minus 4. From here, we can see that the factor they have in common is the x minus 4. So that will be our first factor. And then our second factor will come from here, 2x plus 1. So remember, I multiplied 2 times -4. That's how I got -8. And then we found the factors so that by combining them, we could get -7x. Now for the next one, we do have 6 times 20. That will be +120. However, we're trying to find numbers, factors of 120. So 1 and 120. 2 and 60, 3 and 40, 4 and 30, 5 and 60, 6 and 20, 10 and 12. And in fact, none of those give me 23 when I add them. 120 divided by 8, that could be the one. So we'll go in one time. We carry 4. Oh, great. So 8 and 15. And so the number that we're looking for is 23. So 8 plus 15 is 23. We're actually looking for negative 23. So that would be negative 8 and negative 15. So what we're going to do is break down this term with using this. So 6x squared. And I'm going to go ahead and take this one, negative 8x, and then minus 15x, and then a plus 20. I'm going to group the first two, and then the next two. But still keeping both groups adding to each other. I need to make more room here. So now I'm going to factor each group at a time. For this first one, I can take out a 2, but also an x. Then I will get 3x minus 8x divided by 2x is negative 4. For the next group, I'm going to go ahead and factor out negative 5. So negative 15x divided by negative 5 will give me a positive 3x. And then 20 divided by negative 5 will give me a negative 4. So now that is the factor we do have in common, 3x minus 4. And my other factor, remember, it does come from here and here. So that will be 2x minus 5. And that would be the second factor. Now for this last one, we're going to go ahead and make that transition to find the solution, the x-intercepts, and perhaps we can list the factors as well. Now, if you notice, we have the same polynomial, so we already have the factors here, and this is probably the most important part of this lesson. We have the factors, and those were 3x minus 4 and 2x minus 5. Now, if we do equal those factors to 0, we could take each factor by the zero factor property, equal it to 0, and then solve for x. So this will be 3x is equal to positive 4. So then x will be equal to 4 divided by 3. So that is one of my solutions. Or we also call them roots, or we also call them zeros. So that's one of them. And then our next one will come from the other factor. So the other factor being 2x minus 5, we equal it to 0, and then we solve for x. So that will be 2x is equal to positive 5, and then x is equal to 5 divided by 2. So that will be my next solution, root or 0. Now, because those two numbers are real, we could go from there to x-intercepts. They're real because they do not contain I. And so our x-intercepts as points will be the points with the coordinates 4/3, 0, and the other one will be 5/2, 0. And this will be the end of the video. Thank you for watching. Remember, this was for 0114, which is a co-requisite of 1314.